Hello and welcome to the latest multiplayer update. In today's video we're going to be looking at everything I've changed since the last version, which is a significant amount of stuff, so you should keep your ears open. It's important to note that this hasn't been pushed to my trunk yet, so don't expect anything new in my Blender source until about maybe a week's time or even more, once I've finished removing the Necrosys work from it. So, what's new? Well, first I've added some getState methods to the GameState class. These enable you to access a state packet, or a state dictionary from the server without having to access the dictionaries yourself. Likewise, there is the store state function which does the same task, its respective task. The state type parameter is to define whether it's a server state or a predicted state. Likewise, the state tick defines the tick in which that state was created. If you don't specify the state tick, it will usually use the last received state, or if it is a predicted state, the last stored prediction. As well as this, we also have some other changes. For some reason I noticed that in the client class and the server class it wasn't taking into account the last sent tick. In other words, it was sending data every single game tick, which is why there was such a heavy bandwidth usage and a heavy logic usage. I've reduced this down to 30 times a second and 20 times a second respectively. Or 25 for the... no, it's 25 for the server and 30 for the client. What else have I changed? Well, in the correct prediction there's been a lot of changes. Firstly, using the new methods makes it easier to access user data. I've added a getUserData method which enables you to access the data of a user instance from a state packet, and you can define the type of state you're accessing and the state tick and the user you are requesting for. As well as this, I also added more that you can access and correct in the prediction. So now the prediction includes all of the data in the game that we currently have. So it can correct the clip, the ammo, the health, the weapon type, the position, the team, and so on. I fixed some smoothing on this, so it will smooth the object according to how much of an error is occurring. Anything after an error magnitude of 1, it will simply it'll simply apply the position error. And anything above a magnitude of 4 will assume something has gone wrong, and it will set it to the last received server position. It would also restore the velocity to the user in future. In fact it does, it restores the velocity of the user. So what else has been changed? I also added an error tolerance, because there is a likelihood that in prediction we make a mistake, which is simply due to timing. There is intolerance in frames before we apply the correction. The reason we get timing errors is because in order to store a prediction, because we cannot rewind physics on the server, we instead forward predict on the client. This means that the client actually stores data for tick X as at the time tick X plus the upstream time, meaning that it will be the right data when it is received by the server, hopefully. This is annoying to do, but what it means is that we can get a little bit more imprecise errors. In order to correct this, I added the tolerance as such. And I've also added a raycast function. This raycast function is time dependent. In other words, it will only be applied on the tick specified. Thus, it looks back up the states in the past to perform the raycast. You can actually specify the state type which you wish to raycast against, either the server or prediction states. Furthermore, it will return a user instance, and the way in which I've implemented raycasting is simply to add a bounding box around each user or AI, and then perform a local space raycast. It's not too slow. It's not very slow at all. Actually, it's quite fast. I don't notice it on the logic usage. So that's most of the game state changes. Let me just pause the video and check what else. Of course, what else is different is that there are now custom exceptions for custom errors. There are certain errors which happen within the system which I expect and I wish to catch. These all derive from basic errors like key errors or attribute errors. Thus, I've decided to create a custom exceptions module with specific exceptions for those cases, so that I'm aware of when a system failure is occurring and when a simple game state non-existence is occurring. That's why I've added those. So there's an incomplete state error, which is raised when we can't find a state or it doesn't have the correct values, and also a tick error when a game tick is larger than it should be, which is because the clock synchronization has failed. I've also added a sound manager. I don't know if that was in the last version. The sound manager is also existing alongside the UI manager. Sound manager is basically a simple way of playing sounds. You can specify if it wants to loop, how many times, whether you want to overwrite the sounds on that channel. Channels therefore also part of it, and you can also specify whether you want to cache the file or not. And that's most of that changes there. I removed the underscore contains, well, double underscore contains double underscore function because I didn't think it fitted with the workflow to have a Pythonic containment checking against the rest of the system. So I was checking for if a user was in the user manager, but I was using a contains function rather than just using a has user function, which made more sense in the long run. The local users had a lot of changes. I have let me think what I've done. I've specified we're now using the character constraints and the character physics type, so I've added that in. We're also using frame independent movement. The reason I use the character physics type is it gives me more precise physics, and it enables me to move the player with more precise collision awareness, which is useful because of the fact we can't rewind physics states. The reason that this is now frame independent is that we specified the movement in a vector class, and that movement simply is the transformation of movement speeds, and it is irrespective of the length of the tick. It then divides that movement vector by the length of a tick in order to determine how fast it should move in one frame. This is transformed as world velocity by simply applying the object transform. I've also I fixed states dictionary so that we can find some useful information on the client side, and it will overwrite the active. What have I changed? It will overwrite the active. It'll override the active attribute rather than using the object.active. Instead, it uses the user.data.active. Sorry, the form. What I meant was it doesn't use user.active. It now uses user.data.active. The remote user hasn't seen very many changes at all. In fact, I haven't changed it for the entirety of the system. I just wish to distinguish the two. And that's most of the local user class. Now let's go back quickly up to the network class and have a look there. Oh, actually the clock as well. The clock, I add the poll function, so rather than checking the system time every time it was checked, instead I just return an attribute. I call the poll method every frame. And what this does is it means that the game tick will always be the same throughout the running of the function. Because if the system has two different game ticks on the same actual processing tick, that would cause confusion. So I fixed that there as well. I've also added a variation of game tick rate and local tick rate. I'm not sure if I was already aware of that. And I've also added smoothing of the round trip time so that anomalous results don't affect it as much. This is simply taking a mean of all the values, and we store, I think, about 6 values or so before we start overwriting. So into the first person client, I have, as I've already mentioned, fixed it so that it now stores the last transmission tick, so that it doesn't send a transmission every tick. Raises a tick error if the base or delta ticks are outside of their intended size, because they have to be fit into a struct. I've also modified slightly the I've already mentioned this before, but I've modified the event instances. I'm considering renaming these from events to network events, perhaps, or something that's more self-descriptive. And lastly, oh yes, there's actually quite a lot more that I've changed. I better show you the server. The clients and server are now aware of the rate at which they're receiving data from other peers. And also I've added this instances class module, rather. This instances module gives me single tier access to all of the important classes instances in the scene, or in the function, in the system. So rather than having to access large relationship trees like self.eventManager, .parent and so on, you can now access the module attributes directly, and these can be imported into different parts of the system. Likewise, the server's seen a lot of changes, and have actually most of the classes. I fixed the immutable base class because for some reason it wasn't including vectors do not have an iterable attribute, nor do matrices, so I then made it so that it looks for those inside of a special flagging list, so that it also copies vectors, matrices, Eulers, and quaternions. The data class has seen a few changes as well. I added the movement velocity attribute. The movement velocity is independent of local velocity. Local velocity is the actual velocity per frame of an object. And what else is there? Friction is a new attribute, so the friction of the object, it enables the object to smooth itself and when it's slowing down, rather than simply stopping. I also moved the range the range constant to the constants dictionary. You'll see the states now incorporates all of these attributes here. As well as this, there are all these new box, ray, and sign classes. The box class is simply a bounding box. The sign is simply a way of setting X, Y, and Z to true or false, if you like. It's quite tricky. It's quite a simple implementation, but I wanted to have a class for it. And ray is a ray instance, and this is, you only really need to have ray and box inside of your system. What else is different? Well, if you look into functions, it has a cached property function for cached class properties. There's a clamp function which clamps a value between in a delta range. What this means is that if the value is more than 0, it will clamp it within 0 and the positive value of delta, and if it's less than 0, it will clamp it between 0 and the negative value of delta. That's useful for me. There's also the UI, which has changed a lot. This is the UI for Necrosys, which you shouldn't really have access to, and likewise I will remove it. The events have been changed quite a lot here. I removed the need to access self.parent, and I'm using the instances module now, where I can. I modified some of the print statements down here, and I also stored the receive and transmit rates, as I've already mentioned. So hopefully, the system runs a lot smoother than it was. At one point I was quite concerned with it. It's now running far better. What else has changed? The server, obviously, is an important thing to show you. The server's had quite a lot of changes as well, because a lot of the changes that occur on the client have to occur on the server, as they are very much mirror images of each other in a lot of ways. I didn't actually mention this earlier, but the shooting and reloading functions now use ticks instead of time spans, which hopefully allows them to be a little bit more they're a little bit closer to each other, rather than depending on the time which it happens on a local client. It instead uses the tick. It gives a sense of inaccuracy, which makes it seem more cohesive. Or rather, it gives us a level of accuracy that we couldn't use before. So now we just use a level of inaccuracy that we can be contented with. It also makes a firing sound and uses the new ray casting function. Also, I wasn't checking if the user was inactive, so then I added that as well. So if it's inactive, it will not add your score to your team. I also made sure that the disable function was removed from the user manager and added to the current user class itself. So now users can be self-disabled from self.disable. I also removed the _cleanup function and added a simple delete function. That's for cleaning up, really. I also separated the input events function into two functions: the read inputs and run inputs. Read inputs is run before run inputs, and it now allows us that if we do not have an event in the event queue, we then use the last received event. So what that means is that clients running at lower frame rates who only poll their inputs at 30 times a second rather than 60 will still show the same results roughly on the server. With this new movement velocity functions, the character wrapper comes with an on-ground function, which is very handy. As well as this, I added friction for... We're now moving the object using location displacement, so I added a smoothing function. The velocity persists between frames, but we apply a sense of a friction constant to it. In order to get the velocity to work in world space, we multiply it by the object transform, and I divide it by the tick rate in order to get the velocity for our frame rate rather than the velocity for the server frame rate. Costs a lot of changes. So that's most of that. Cleaned up some of this up here, it was a bit annoying me. Oh dear, what I pressed. I've added state constants as well, as I've already mentioned, for the server or predicted states. Obviously this is very much limited use on the server who only has one state type at the moment. And I think that's most of the changes. Generics. Yes, that's all of the changes for now. I'll keep you posted. That was a lot of stuff, so I'll keep you posted in the future. Thank you for watching.